This is topic 7.8, representations of equilibrium. Today's objective is to be able to represent a system undergoing a reversible reaction with a particulate model, and also you're going to be able to do that with some graphs as well. So we've seen before that we can model reactions based on the relative number of particles, then making sure that our numbers are consistent, which is one of the things that we talked about. So a couple of things to be mindful of with a particle diagram. When you're doing these reactions, make sure you have the appropriate amount of your moles, your shapes, etc. Whatever the initial or the first one they give you, you have to make sure that you are keeping the number of particles in mind. So for example, if you have 1 mole and it's, let's say, two circles, for example, that are separate, if it's increasing the number of moles in the next square, you have to, so if it's 1 mole to 2 moles, it means it's doubling, so you have to double your number of, double the number of circles you have, so it would be 4 circles or something like that. So just as something to kind of keep in mind, we'll go through a couple of examples with this. You can also use graphs to indicate your how your reactants products change. So as you can see on the y-axis, we have our different concentrations, and we start off our reaction at equilibrium. However, as it was shown in the previous slide, new product was added. So after that, after some new product is added, your equilibrium is going to have to shift based on the fact that new product was added to the system, so to speak. So consider the following reaction. You have N2 plus 3H2 produces 2NH3. Let's say we have 6 moles of nitrogen, 6 moles of hydrogen, and 6 moles of ammonia at equilibrium in a 2-liter container. Draw a possible equilibrium showing that how the number of reactants and products might change if the volume was reduced to 1 liter. So this just my work for this particular problem. So just a reminder that my equation was N2 plus 3H2 produces 2NH3. So I'm focusing on my coefficients for a reason. So if you're given a diagram like this, you have to kind of keep consistent with the shapes, the number, etc. So we can see that for my N2, we have 6 because of the moles and all that. H2, we have 6, and NH3, we also have 6. So according to the question earlier, I'm at equilibrium, but I then decrease my volume from 2 liters to 1 liter. So by decreasing the volume, by halving it, you're actually increasing the pressure by 2. Just something to kind of keep in mind. So the question is asking for a possible diagram for basically what could this possibly look like, possible equilibrium. So to kind of keep it simple for this, something you need to be mindful of though, when I increase the pressure, I'm actually going to shift the reaction to the side with fewer moles of gas. Therefore, for this reaction, it's going to shift towards the products. So again, I'm focusing on my coefficients. So this reaction is occurring stoichiometrically. So to make it simple, if I lose 1 N2 and I have, so based on this, if I lose 1 N2, I'm losing 3 H2s. But because to kind of produce the reaction, so to speak, I'm gaining 2 NH3s here. So it's going to be kind of hard to do with the size of the box, but I'll see what I can do. So I'm going to kind of try to keep consistent. So I have 5 N2s, so it's going to be the bigger blue circles. 1, 2, 3, 4, 5. I have 3 H2s that are going to be lost. Or, I'm sorry, that's all I'm going to have left. I apologize for speaking. And then I'm going to have now, oh gosh, 8. Let's see if I can do this. 8 NH3s. God help me. Okay, let's see. Yeah, so it's kind of hard to, sorry, I did that wrong actually. Make it easier. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8. So wherever I put the single blue circles, I'm going to add 3 small ones. So it's not perfect, but it gets the general idea across. So obviously you're not going to have colored pencils on the test, so maybe just a good idea to try to be as consistent with your drawings as you can. So now we're going to try to graph out how the amount of products and reactants will change. It's the same scenario. So if I have 6 moles of nitrogen, hydrogen, ammonia, it's in 2 liters. What will happen if it's reduced to 1 liter? So by going from 2 liters to 1 liter, so remember that I'm halving the volume, so I'm actually going to double the pressure. So the y-axis you see, there's no real specific number, it's all kind of relative to each other. So just kind of remember that if you are increasing the pressure, you will shift to the side with a fewer moles of gas. So what's going to happen, I'm going to draw this vertical line here that should kind of resemble twice the pressure. So what happens at those 3 lines, this is my container reducing. So this is so the pressure doubles. So I'm going to be at a certain point right here. So wherever it hits that double pressure, something's going to happen when this thing reaches equilibrium. So like we said, I'm going to shift towards the product. So I'm going to have more products. So I'm going to draw this out right here. Maybe a different color might help. Go up like this. So this, let's just say that my product increases by 2x or 2 times 2x, whatever the number is. However, now, kind of keeping that in mind, my 2 reactants will decrease. So if that's 2x, I got to resemble sort of 3x. So I'm going to try to make it so that if this is 2x from here to down here is about 3x. For N2, it goes down just by 1x, so I was probably trying to make it half of the one on top. Sort of. I guess it's okay. All right, so if you have any questions, please let me know. Thanks.